Hello and welcome to Down the Well with GravWell, where we explore use cases and scenarios that readily apply to real-world security analysis. Often, security intelligence teams receive finished intelligence reports from providers, partners, or open source. While many organizations consume these reports to productionize their included indicators of compromise, mature security teams are capable of distilling key tools, tactics, and procedures, also known as TTPs, from reports and writing detection logic to better equip their organizations against threat actors. In this video series, we will use GravWell to pivot on several indicators contained in an intelligence report to discover the underlying TTPs that threat actors used within our environment. Then, we will take those TTPs and distill them into detection logic that can be rendered back into GravWell as deployable detections, which can be controlled and customized with a no-code automation feature, Flows. We will be using data from KC7, a link can be found in this video's description. The data in KC7 was built by cybersecurity experts to simulate real adversaries. Therefore, it is synthetic but realistic. Since it was designed for educational use, we're going to use this data in this video in order to make it easily consumable by a broad set of users. While there are multiple ways in which we can think about detection within GravWell, we will primarily emphasize a mode which requires a search extraction module. This will allow us to use more search processing tools and less computationally expensive field comparisons. Please check this video's description for the links to the data source and the faux intelligent report. In the description, you will also find a list of all the queries that we used for this exercise. First, let's load up the GravWell Query Studio. We have pre-populated the various tabs with the queries that we will showcase today for the sake of brevity. While many organizations tend to rely on indicators of compromise as the key to threat actor detection, good detection engineers recognize that these indicators are often just initial pivots for discovering tools, techniques, and procedures. Let's pivot on some indicators included in our faux intelligence report and see if we can uncover any additional insights into our threat actors. First, we'll see if we can find any lure documents in our environment. Looks like we have hits in our environment across multiple data sources for our suspect lure documents by name. We can see hits for email, outbound browsing, and file creation events, which likely indicates at least one user has gone through the entire process of opening a phishing message, browsing the download link, and downloading the lure document. Since we've already seen what happens to be a full chain of user interaction with a phishing lure, I think we should check for any hashes that match the reported implants. Wow, that's a lot of hits. It looks like the most interesting entries are in the process events data source. Since we are really looking for threat actor behaviors, let's run the same search but restrict it to the process events tag, parse it to the enumerated fields, and render it as a table for readability. This is a good high-level view of threat actor behaviors in regards to known indicators of compromise and how they relate to process invocation. We have quite a number of entries that match our query, and a quick browse shows us that we have several different process command line combinations. We can quickly get an idea of different process command line combos and their frequency by adding a few search processing tools to our original query. Looking at the results, we can see that the threat actors like to use ping 8.8.8.8, which is Google's DNS server, and is pretty typical for network connection tests. And then a who am I for orientation. And we can see a plethora of p-link with some bespoke IP addresses. Let's focus on the threat actor's usage of plink.exe in our environment, as this is a particularly high confidence signal that the threat actor is able to interact with the affected host. We can see this threat actor plink activity on multiple machines in our environment, and all our results appear to be true positives. So this could be a reasonable detection to create, but we know that the threat actor has invoked additional executables from the first stage implants. We could expand our query to cover that scenario. For this query, we'll use a logical OR sequence with our grep search processing module. Our more inclusive result set now includes a threat actor ping and whoami activity. Interestingly, while browsing through our results, you'll notice some file names that may not have been included on the original report. So let's dive a bit deeper to get a list of all the file names that have been seen invoking these three executables. This is specific to what we have observed for the threat actor's tooling, but it actually expands beyond the scope of the initial report, which indicated that the threat actor used only the names green.dll, ham.exe, and samiam.dll. In our results, we see additional names such as egg.exe and another set of activity that the report mentions as a second stage set of implants exhibiting the same activity. svhost.exe, recordsvr.exe, and infector.exe, with the net new finding of updater.dll that is also likely related. So, by being more tolerant with our query logic, we were able to identify two new file names that were not included in the original report. While our query for parent processes that are not command.exe that have command lines with plink, whoami, or ping is adequate for detecting this particular adversary's past behavior, let's build a more generic query that we could use as part of automated detection workflows. Since we have seen the adversary directly calling IP addresses as parameters in their command lines, why don't we try looking for any processes that have an IP address in it? In this case, we'll look for any process command line that follows this regex pattern. These results look pretty promising so far. We can see our plink activity, some putty, and some other kind of activity, but let's not stop there. Let's create and test a final query that we'll use for our detection flow. For this query, we've removed some of the count and sort options from the last query in order to render our results in a more complete fashion. Now that we are satisfied with our query after exploring our data, we can move into automating our detection and notification process using GravWell Flows. In the navigation sidebar, select Automation, and then select Flows. The Flows screen shows all your existing flows and allows for sorting and searching. Here's a flow that we have created for our IP address detection and process command line query. Let's select this flow and break it down into its component nodes. When selecting a specific flow, we first land in the Flow Designer. Let's swap to Info and Scheduling to name our flow and add a description. In this case, it's IP detected in process command line, and then go ahead and give it a description. Then, we flip back to Flow Designer to access our palette of nodes. Let's check out our first node, which is the Run a Query node. Once we select our node, our right side workbench shows the settings. We are setting the query to run at flow.interval, which is a shortcut to just run at any time the overall flow is scheduled. And just looky there, it's our query that we originally wrote in Query Studio. Now swapping back to our Info and Scheduling tab, we can see this flow is scheduled to run every 12 hours. That means that the flow will run every 12 hours with a 12-hour lookback for the query. And for our outgoing payload variable, we will choose search. Here are the facets that payload object includes. Now, we need to apply some logic. We want a notification to be sent only if there are results. So let's add an if statement node to our flow. If the total number of results as defined by search.count is greater than or equal to 1, i.e. we have at least one result passed through our notification email notification node, here's what we'll pass to our email node. You can see it's the same search data. This is just acting as a filter. Now, let's look at our notification node. In this case, we will send an email if there are any results from our query. Here we have set up a sender, recipient, a subject that is derived from the flow name, a placeholder body, which should ideally contain instructions for the analysts, and finally, we attach a CSV file for our query results to the email for the analysts to review. For testing purposes, we will use an advanced query node. The advanced query node gives us control over the start and the end time in which a query runs. Since our data is historical, we will use this to test our detection over a period of time we know should generate hits. No other logical changes are being made. We test our flow by pressing the play button, run flow, and debug. Now, expanding the information at the bottom, we can see our advanced query worked, our if node worked, and our email node worked. Now let's go see what that email actually looks like. Checking out our inbox, we can see the email has been sent successfully. Our sender, our recipient, our flow name are all correct, and it also includes our really terrible notes. Probably should add more if you're really doing this. Anyways, it also includes our CSV attachment. Let's go ahead and take a look. Opening our CSV, we can see a rendered table of all of our results for the day we ran our query. And as expected, we see a number of process command lines with IP addresses in them. To wrap things up, in this video series, we used GravWell's automation flows as an ideal complement to the data exploration capabilities enabled by the query engine. From a vendor intelligence report, we were able to explore our data and iterate on potential mechanisms for detecting threat actor activity. With GravWell, it was easy to test ideas and potential detection logic and carry the same logic over to automated flows to create scheduled queries and notifications. And thank you again for joining us in this session of Down the Well with GravWell. If you want to make use of your newfound knowledge, I invite you to hop on over to gravwell.io/CE and pick up our community edition. This is free for both personal and commercial use. It's entirely complimentary and is accessible via license request at gravwell.io/CE.